Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to explain the difference between distance and displacement. We will start with an example. Here we have a guy at home at a position 0 meters, and he will walk through the tree which is at position 50 meters. And now he covered a certain distance and he had a certain displacement, and we will both see how big they are. So first the distance he covered was 50 meters because he went from 0 meters to 50 meters, so he covered a distance, also the small letter d, of 50 meters. The displacement is a little bit different. It's delta x, and you have to calculate it with the final position minus the initial position. So his initial position was 0 meters, his final position was 50 meters, so we subtract the final position, the initial position from the final position like this, and we have a displacement of 50 meters. So in this case they are the same. The distance he covered was 50 meters and the displacement was also 50 meters, but it's not always like that. For example, the next example. We have the same guy standing at his house, and he's now going to walk through the tree, and then he is going to return back home. And again, he covered a certain distance and he had a certain displacement. First the distance, he walked 50 meters to the tree, he walked 50 meters back, so his total distance was 50 plus 50 is 100 meters. His displacement, well, we have to first determine his final and his initial position. So he started at 0. So his initial position was 0, his final position was also 0. So 0 minus 0 equals 0 meters. So his displacement was 0 meters. So now you can see there's a difference. Although his distance was 100 meters, he did not have a displacement because he returned at the same position. So there's a big difference between distance and displacement. Another example, you can try this one for yourself. You walk to 3b, so you walk here, and then you walk to 3a, so then here. And you have to determine the distance and the displacement. So try it for yourself. First the distance, you walked from 0 to 60, so that's 60 meters, plus 80 meters, because from 60 to minus 20 is 80 meters, so that is 140 meters. The displacement, well, you started at 0, you ended at minus 20, so the starting position was 0, the final position was minus 20, so minus 20 minus 0 equals minus 20 meters. So your displacement was minus 20 meters, so you that's the place where you then ended up. So as you can see, a big difference between the two, and you have to know this difference. Another example. So try it for yourself. As you can see, now his starting position is not 0 meters, it can also be already 10 meters, so the 0 is somewhere here, but it works the same. So try it for yourself. He will walk to the 3b, and then he will walk to 3a, and he will end up back home. So he walked to b, then to a, and then back home. So now determine his distance and determine his displacement. Well, for the distance, he first did 40 meters to b, then 80 meters to a, because he returned the 50 there, and then he went to minus 30, so that's in total 80 meters, and then 40 meters from minus 30 to 10, so in total he did 160 meters. That was his distance. His displacement, well, he started at 10, he ended at 10, so 10 minus 10 is 0 meters, so he did not have a displacement. So as you can see, the starting position doesn't have to be 0. It's the one that we give it, and it can be any number. In this case, it was 10. So now the big difference, the distance is a scalar. Its direction is not important, so it doesn't matter if you walk left or right, you will always have a positive distance, and it's always positive. So you cannot have a negative distance. Displacement is a factor, so that means that not only the magnitude but also the direction is important. That's why sometimes you have a displacement which is positive, and the other times it's negative, and the negative means that the direction is a different way. This can be any number, it can be positive or it can be negative. Not like the distance can only be positive. So these are the big difference between distance and displacement. Well, an example again with some strange numbers. Try to see if you can figure it out. You start here, you walk to 3b, and then you walk back home and determine the distance and the displacement. So first the distance, you walk from minus 22.5 first to 0, so that's why it's 22, and then you walk more to 32.1. So you add them together, that's the first distance you cover, plus then back home. So that's the difference between those two, and it equals 79 meters 79.3 meters. This one is a little bit difficult. The displacement is a lot easier. Well, you first have the final and the initial position. So his initial position was minus 22.5. His final position was 7.4 because that's where he ended. You calculate it, and it's 29.9 meters. So his displacement he's 29.9 meters to the right because it's a positive number from where he started. Another example can also look like this. You walk from start, so you start here, to C while passing A and B. Determine the displacement, the distance and the displacement. So try this for yourself. First the distance, you walk 450 meters, then you walk 300 meters and then 550 meters. So you add them all together and the total distance you covered was 1,300 meters. Displacement, well, you started here. Let's say it's 0, so this one will be 455. So 455 minus 0 is a displacement of 455 meters. And to be correct, you should also add the angle, because you now didn't go left or right, you did go not straight up, but a little bit up. But in this case, it wasn't given, so his displacement will be 455 meters. But for the correctness, also an angle should be given. That's it. I hope you now know what the difference between distance and displacement is. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.